Welcome to the DIY Honda Garage channel. The DTC P0101 is a diagnostic trouble code that indicates a mass airflow sensor circuit, range, or performance problem, specifically for the 2022 and later Honda Civic models. The mass airflow (MAF) sensor serves a critical role in ensuring that the engine receives the correct amount of air for optimal combustion. It measures the volume and density of incoming air, sending vital data to the powertrain control module (PCM) to adjust fuel delivery as needed. A problem arises when the MAF sensor output frequency falls outside of an expected range, prompting the PCM to store this diagnostic trouble code. Understanding what triggers this code can help technicians conduct efficient troubleshooting to maintain the performance and emission standards of Honda Civics. Addressing P0101 promptly is crucial to prevent further complications in engine performance and efficiency. The DTC P0101 signifies that the mass airflow sensor is experiencing a circuit range or performance issue. When the PCM, or powertrain control module, detects that the frequency output of the MAF sensor is outside its specified range, it identifies this anomaly, leading to the storage of the DTC. The MAF sensor is typically located in the engine bay, specifically within the intake air duct after the air cleaner element. Its role involves measuring the air entering the engine to enable the PCM to regulate fuel injection properly. Understanding the MAF sensor's location and function is vital when addressing diagnostic trouble codes, as it directly impacts engine performance and efficiency. Consistent data from the MAF is key for maintaining optimal air-fuel ratios, essential for the vehicle's overall operation. Several possible causes can lead to the triggering of DTC P0101. A defective MAF sensor could directly cause the sensor to output incorrect readings, which the PCM interprets as a fault. Additionally, physical damage to the intake air system, such as leaks or cracks, may not allow proper airflow to the MAF sensor, leading to performance problems. An obstructed air cleaner can also inhibit airflow, affecting the MAF sensor's ability to function correctly. Each of these components plays a crucial role in the air intake system, and failure in one can result in far-reaching implications for engine performance. Therefore, a thorough inspection of these areas is imperative for accurate diagnosis and effective repair. The symptoms associated with DTC P0101 are critical to recognize for effective troubleshooting. One of the most noticeable issues is a decline in engine performance. Drivers may experience sluggish acceleration or stalling due to improper air-fuel mixture ratios. Increased fuel consumption is another symptom, as the engine may overcompensate for perceived lower airflow. Additionally, activating the check engine light is a common response to the detection of a DTC, prompting the need for immediate attention. Being proactive in identifying these symptoms can help maintain vehicle performance and prevent minor issues from escalating into costly repairs. Understanding how these symptoms manifest in the vehicle aids technicians in isolating the root cause of the DTC efficiently. The first step in troubleshooting DTC P0101 involves starting the engine and holding the engine speed at 3,000 RPM without any load. For automatic transmission vehicles, it should be in Park P or neutral N, and for manual transmission vehicles, it should be in neutral. This step is essential because it allows the PCM to assess MAF sensor readings under a controlled condition and establish baseline data. After maintaining this RPM for a specific time until the radiator fan activates, it's crucial to let the engine idle for at least 5 seconds. This period allows for the stabilization of various engine parameters, aiding in accurate diagnostic outcomes. Valuing these steps ensures that the technician gathers significant data for further analysis of the MAF sensor's performance. In the second troubleshooting step for DTC P0101, the next directive is to drive the vehicle at a consistent speed of 37 miles per hour for at least 5 seconds. Maintaining this velocity allows for an assessment of the MAF sensor's responsiveness under driving conditions, simulating real-world operations of the vehicle. During this period, the technician should monitor the MAF sensor readings, as fluctuations or irregularities can indicate the underlying cause of the DTC. The PCM continuously gathers data from the MAF sensor to ensure the correct air-fuel mixture is achieved for optimal engine performance. After this step, a clear understanding of the sensor's functionality can guide more focused inspections and repairs based on the results observed. The third step in troubleshooting DTC P0101 revolves around a thorough inspection of the intake air system to identify any physical damage or abnormalities. Specifically, technicians should examine the connections, hoses, and components leading to and from the mass airflow sensor. Key focus areas include the positive crankcase ventilation (PCV) valve and its associated hose, as these components can influence airflow and sensor output. Any damage or blockage found in these areas could significantly impact the MAF sensor's functionality and consequently engine performance. This step is critical because it serves as the foundation for diagnosing potential mechanical failures that may be affecting sensor performance, ensuring that each component works in harmony within the system. The fourth troubleshooting step involves conducting a visual inspection of the air cleaner housing and intake air duct system. This inspection is critical for identifying any physical blockage or damage that may interfere with proper airflow to the mass airflow sensor. The air cleaner must be assessed for cleanliness and structural integrity, as any contaminants or obstructions can distort the airflow measurements provided by the MAF sensor. Likewise, the intake air duct requires careful examination for leaks or cracks that could also compromise airflow, thus affecting engine performance. Finding and resolving any issues in these components can lead to significant improvements in MAF sensor operation, facilitating a smoother engine performance and potentially resolving the DTC. In the fifth troubleshooting step for DTC P0101, technicians perform a functional check of the mass airflow sensor via the Honda Diagnostics System, HDS. Initially, it's important to confirm that the HDS is assessing the MAF sensor while the engine is turned off. The normal range for the MAF reading should be between 520 to 10,000 Hz. If the readings fall outside of this range, it strongly indicates that there is a problem with either the MAF sensor or the intake air temperature sensor, IAT1. This step is crucial because it allows you to isolate the issue, whether it's the sensor itself or another influencing component. Understanding the data provided by the HDS enables more efficient diagnosis and streamlining the repair process. The sixth troubleshooting step entails starting the engine and allowing it to idle while once again observing the readings from the Honda Diagnostics System, HDS, for the mass airflow sensor. Under these conditions, you need to confirm that the HDS displays the same normal frequency range of 520 to 10,000 Hz. A reading within this range indicates that the MAF sensor is functioning correctly, allowing for proper air-fuel mixture adjustments by the PCM. If the MAF readings are abnormal during this idling condition, this points towards a malfunctioning MAF sensor or a potential influence from the intake air temperature sensor, IAT1. This analysis is critical for determining whether the sensor is faulty and requires replacement, or if further troubleshooting is necessary. Once troubleshooting is complete, the final repair verification step is essential to ensure that the issue signaled by DTC P0101 is fully resolved. This involves a recheck of the mass airflow sensor function, monitoring its outputs through the Honda Diagnostics System, HDS, again, to see if normal readings have returned. Additionally, it is crucial to confirm that no DTCs remain in the system, which indicates all faults have been addressed effectively. Following this, taking the vehicle for a test drive under various conditions allows technicians to observe MAF functionality in real-world scenarios. These steps ensure that repairs have been successful and that the vehicle operates at optimal performance levels, enhancing reliability and efficiency long-term. Preventive maintenance is essential for avoiding future occurrences of DTC P0101. A key practice is to conduct regular checks of the mass airflow sensor, ensuring it remains free from contaminants and functioning within the specified range. Additionally, sticking to a predetermined schedule for air filter replacement helps maintain optimal airflow, significantly reducing chances of blockages that could affect the MAF sensor's performance. Regular visual inspections of the entire intake system allow for early detection of any signs of wear, leaks, or obstructions. By incorporating these preventive measures into routine maintenance, vehicle owners can enhance engine efficiency and prolong the lifespan of essential components, thus improving overall vehicle reliability. In conclusion, DTC P0101 serves as a critical alert for issues related to the mass airflow sensor circuit in the 2022 Honda Civic and later models. Understanding the symptoms, potential causes, and effective troubleshooting steps is vital for timely diagnosis and repair. Thorough inspections of the MAF sensor, intake system, and associated components can help technicians identify and resolve the issue efficiently. Engaging in preventive maintenance practices ensures optimal performance and mitigates the chances of recurring issues, leading to better reliability. Should DTC P0101 appear, addressing it before it escalates into more severe problems is essential for maintaining the vehicle's performance and ensuring a smooth driving experience. Please like and subscribe to the channel. See you next time.